Hello, and welcome to the Learning Enhancement session on the periodic table for Key Stage 4 Chemistry. Before we get started, can you please make sure you have a pen, a pencil, a ruler, a highlighter or a coloured pencil, and your journal because you're going to need your periodic table or a printed periodic table if you can. Okay. Can you just pause the video just for 10 seconds and write down the learning objective to understand how to use the periodic table? Okay. So, we're going to start off with retrieval questions here. Can you pause the video for 4 minutes and answer the 3 questions and the extension in that time? So pause the video now. Okay, your time is up there. Can you please pick up another coloured pen or pencil and we'll go through these and give yourself a mark. Okay, so question 1, just simply ask, what is an element? Hopefully you got that an element is a substance that cannot be broken down into something simpler, and it can also be found on the periodic table. Okay, what is a compound? Simply 2 or more elements chemically bonded together, they're joined together. So 2 more different elements that are chemically bonded together. Okay, what are the following elements? So you've got O, N, Na, Mg, Al, Co, and Zn. It is oxygen, nitrogen, sodium, magnesium, aluminium, cobalt, and zinc. Give yourself a mark for that. And then, extension question, what is the difference between atomic number and mass number? The atomic number is the number of protons or electrons in the atom only. The mass number, however, is the number of protons and neutrons in the atom together in the nucleus of the atom. Okay, so give yourself a mark out of 3 or 4 if you did the extension. Okay, so what we're doing today, just going to refresh our knowledge on the periodic table. The periodic table contains all the known elements. Before we get started, can you please draw in this diagram here and then label with the arrows there. So draw the diagram and add the labels. Give yourself 2 minutes. Go. Okay, just going to quickly go through this. Give yourself a mark out of 5 for this in green pen or an old pen or pencil. So the proton is found in the center of the atom, the nucleus of the atom, as well as the neutron, which are also found. Electrons, however, are found on the outside, on the electron shells around on the outside of the nucleus. The nucleus being in the middle, containing both the protons and the neutrons, and empty space is just in between that, in between the nucleus and the electrons on the outside. Okay, so just give yourselves 10 seconds just to think about this question. What do you think the red line represents on the periodic table here? So just give yourselves 10 seconds, have a think, jot it down, have a think. Okay, hopefully you got the idea that there's, on the left hand side of the staircase, the stairways as it looks like, are metals. All these here on the left hand side are metals, and that means on the right hand side, to the right of it, it's non-metals. So the red line separates metals and non-metals, so metal and non-metal elements on the periodic table. Okay, so hopefully you've got a periodic table in front of you. If not, you pause the video and make sure you have one in front of you. Can you look for the symbols of these 5 elements here? Look for the symbols on them. Pause the video for just 2 minutes. Find them, just jot them down, and then we'll go through them. Okay, 2 minutes is up there. I'm going to quickly go through these and give yourself a mark out of 5 as I'm going through this. So, lithium on your periodic table, hopefully you found out that was Li. Iron, obviously Fe. Calcium, Ca. Zinc, aluminium, zinc, which is Zn, and then aluminium, which is Al. Hopefully, what you notice about each of these symbols is the periodic table rule that if the symbol has 2 letters, the first letter always has to be capital, and the second letter is always lowercase. But if it's 1 letter only, it will only be a capital. Okay, so having just done that, can you pause the video for 2 minutes again, and then can you tell me what elements these are, and also how can you correct them as well? And then as an extension, what groups in the periodic table do you think they are in? And that will link to the next task. Okay, pause the video for 2.5 minutes. Give yourself 2.5 minutes now. Okay, so you had your time there, 2.5 minutes. Can you pick up another gold pen or a green pen if you do have one? And we'll go for this now. So, Ca, it should be written C, capital C, lowercase a, and that is calcium. Na, just like that, capital N again, that's sodium. Si, that's silicon. Xe, it's just the other way around, it's xenon, a noble gas, group 0, group 8. And Br, other way around, capital B, lowercase r, and that's bromine. Okay, what groups were these as an extension? Calcium is group 2, Na, sodium is group 1, silicon group 4, xenon is group 0 or group 8, both the same group, and bromine is group 7. Okay, so the numbers on the symbol, so every symbol on the periodic table has two numbers, the big number and the small number. The big number is usually the top of the symbol and the small number is usually below, but sometimes that can change. Just like this. So we've got a big number. So for example, using oxygen as example, we've got 16 there, 8 there, the bigger number on top, and the smaller one on the bottom there. I'm going to find out what those are now. So elements on the periodic table are arranged in order of their atomic number, the smaller number. So if we go back there, it's 3. So it starts off 1, 2, 3, 4, and all the way all to, and this one 89, the small number. So arranged in atomic number, the small number. Just like that. So, can you pause the video and just write down these rules with an example here? So pause the video, write down these rules. Okay, thank you. Okay, so now hopefully you understand the difference between the atomic number and the mass number. Mass number is always the biggest, atomic number is always the smallest, but they're not always in the correct order. Sometimes they're swapped around, so the bigger number might be on top. Just be aware of that. Okay, just a couple of information here. Columns on a periodic table are called the groups. So the columns going down here, so 1 there, 2 there, 3, 4, so the numbers there show that they're called the groups, and rows are called the periods. So each row going across is a period, and that is why it's called a periodic table. It's arranged in periods as well. Okay, so can you now have your periodic table in front of you in your journal or on a paper and have a highlighter or coloured pen to have at hand? We're going to highlight each part of the periodic table, what they are, so you can understand which group is what and understand how to use a periodic table. So, can you highlight the group 1 element here? And can you pause the video just for a second? Okay, so that's all these are group 1 elements. A little information about group 1. Elements in the same group have similar properties, so no matter the group, all the elements in that group, so group 1 here, will all have similar properties, not the same properties, similar properties, and that's due to the electronic structure, but more about that later on in the topic. So the key thing you need to know, the further down the group you go, so lithium all the way down to francium at the bottom, the more reactive they become. So have a think, what would you think would happen if you put francium in water right at the bottom? Have a think. Yes, that's right. Francium will react more violently compared to lithium, and it'd be explosive and reactive, and that cause dangerous explosion. Okay, can you now, in front of you on your journal and your periodic table, or your printed periodic table, can you highlight group 3 elements? And can you pause the video now? Okay. Can you also highlight group 7 elements here? So fluorine all the way down to acetine. Can you highlight that and pause the video again? Now, bit of information about group 7. Again, all elements of the same group have similar properties, but the further you go down the group this time, the less reactive they become. So fluorine all the way down to acetine becomes less reactive. That means fluorine is the most reactive, and it's more reactive than chlorine, bromine, iodine, and acetine. And bromine is more reactive than iodine, chlorine is more reactive than bromine, and so forth. So as you go down, it becomes less reactive. All the elements become less reactive. Okay. And then can you also highlight the final one here? Pause the video. Just highlight group 0, group 8 elements just here. These are all unreactive noble gases. They're unreactive. That means you don't react with any other element. Okay, continue on with highlighting the periodic table. Now we're looking at going across on a horizontal part of your periodic table. Now these are called periods, remember. So period 1 is period 1 elements are only hydrogen and helium. Can you highlight those? Hydrogen might be over on the left hand side in your periodic table. It's still in the same period though. So pause video and highlight that. Period 3, just across here. You can do that there. That's period 3. Pause video, do the same again. There are no period 3 transitional metals. So period 3, period 2, or even period 1 transitional metals. So just make a note of that. But there are period 4 and period 5 and so forth transitional metals. So can you make a note of that? Thank you. Okay, we have a simple true or false questions here. So 1 to 8 in the margin, please. Can you pause the video for, say, 4 minutes? Can you read through statements and write them down and then tell me whether you think they are true or false? That's it. So true or false, write down the statements, 4 minutes, go. Okay, your time is up there, 4 minutes is over there. Can you pick up a green pen or another coloured pen or pencil, and we'll go for this now. Okay, so question 1 simply asks, the periodic table lists elements in increasing atomic number. Is that true or false? Correct, that is true. Number 2, horizontal rows are called groups. Fortunately, that's false because they're called periods. That's why it's called periodic table. Vertical columns are called families. Incorrect there, false again. They're called groups. Lithium and fluorine are in the same group. False. Lithium and fluorine in the same period. However, that is true. Remember, if you're going across, they are both in the same period. Okay. Potassium and sodium have similar properties. True. They are in the same group, so they have similar properties. Potassium is more reactive than sodium. That's true. And then chlorine is less reactive than bromine. That's false. Remember, as you go down, it gets less reactive. Thank you. Okay, so give yourself a mark out of 8 there. Excellent if you got 8 out of 8 there. True understanding. 7, well done. 6, very well done. 5, good. And then 4, 3, 2, and 1. You need to improve on that. Let's focus on improving there. Okay. So, moving on to the final task, final progress check. Can you write 1 to 5 again in the margin and answer these 5 questions? This time, pause your video for, let's say, 3.5 minutes, 4 minutes. Now. So your time is up there. You've hopefully given yourself 3.5 to 4 minutes there. We'll go through these now. So can you pick up a green pen or another coloured pen? And we'll go for this now. Okay, so question 1 asks, how many elements are there on the periodic table? Well, actually, you don't have to count them up. An answer of over 100 would be sufficient. That'll be fine. Over 100. Okay, what is the name of the columns on the periodic table? As we've already stated, the groups going down, vertical columns. What is the name of the rows on the periodic table? They're called periods. What does the number at the top of the column tell you? So above each column, that's the group number. So if it says group 1, 2, and so forth, that's the group number. And then who created the modern periodic table? Bit of history there. It is Dmitry Mendeleev, a Russian scientist who used others to inspire what is now the modern day periodic table. Okay, hopefully you've got a good understanding of how to use the periodic table and a bit of why it's set out the way it is. Thank you.